y equals kx, and k can't equal 0, so this is k times x. And so what happens in a direct variation is if y is going up, x is going up. If y is going down, actually it's actually the opposite. If x goes up, that causes y to go up, because x is the domain, y is the range. If x goes down, y goes down. Okay, that's a direct variation, so they go the same direction. The constant of variation, it's also called the constant of proportionality, is that k. And k is a number. So you might have like y equals 2x, where k would be 2. And that tells you that for every x, y is twice that much. Okay. So to find the constant of variation, if you have the equation of the line, it's just that number that's attached to the x. If you don't have the equation and you just have a line, we can count from one point to the next. I'm going to go down 1, 2, 3, 4, and then over 1. So my slope is -4 over 1, -4. And so you'll notice that slope, m, and the constant of variation, k, are the same. Okay, so your constant of variation is the same thing as your slope in a direct variation. So I have the equation, so k is 1/2. So I'm going to say, okay, my slope is going to be 1/2, and we can double check it. I go from here to here. I'm going to go 1, 2, 3. So I'm going to go up 3. 1, 2, 3, 4, 5, 6. Over 6. So they're the same. Direct variations always pass through 0, 0. Okay. See, they're here and here. So you can find the slope of any line no matter where it is on the graph. You could find a slope of some line way up here. But if it's a direct variation, it has to cross through 0, 0.
Oh, so it's
Now remember, they always pass through which point?
0,
0,
0.
0. So that's going to be where you start. So we're going to start at 0, 0. Okay. So that's our starting point right there. Okay. Our slope, k is the same thing as m, and it's -6, right? Which is the same thing as -6 over 1. So what you're going to do is you're going to count. It's -6, so I'm going to go down 6 and then over 1. It's from 0, 0. So I'm going to go 1, 2, 3, 4, 5, 6 down. Oops. Darn it. 1, 2, 3, 4, 5, 6 down, 1 over, and make another dot. And then you're going to just connect them. Okay. Bless you. Connect the dots. Okay, here, same thing. I'm going to start at 0, 0. On a direct variation, you'll always start at 0, 0.
How you know which one is a direct?
Do you see how it's just 2/3 x? So if it just looks like this, where it has some number and then an x and there's nothing else going on, then you know it's direct variation. So it's just y equals some number and then x.
And then so that one has this
Slope
direct.
is 2/3, right?
Mhm.
And so it's positive. So I'm going to go up 2 and then over
Three.
3. So from here I'm going to go 1, 2, and then 1, 2, 3.
So that's all you gotta do.
Uh-huh.
And
And
then for the
then
other one you gotta do more, right?
connect your dots. For other equations, yeah, you'll have a little bit. Well, it'll be the same process. It starts in a different place. But for this, where you just have y equals some number times x, this is all you do. You start at 0, 0, and then you look at your k, which is the same as your slope, and you just count spaces. It's just counting. If it's positive, you go up first and then right. If it's negative, you go down first and then right. So the equation's y equals kx, and k can be any number, but not 0. So it can be a fraction, it can be a decimal, it can be any number. Usually it's a fraction or a whole number. It just can't be 0. It always passes through 0, 0. Okay. If k is positive, your graph is going to look something like this. Okay, it's going to go through 0, 0, and then it's going to be pointing this direction. If k is negative, it's going to look something like this, where it's pointing down. But it always will go through this point right here, 0, 0. The k is the same thing as slope, which is usually m. So k and m are the same thing. They're both the slope. You're given two numbers. You're given x and you're given y, and you're told that y varies directly as x. Okay? Well, whenever you're told y varies directly as x, that means you're going to get y equals kx. Okay, that's what this sentence right here means, this. Okay. So what we do is they give us y and they give us x. We don't have k. So you take the y, 72, is equal to k times 8. So here's y, here's x, right? So to find out what k equals, I'm going to divide both sides by 8. 72 divided by 8 is 9, so k equals 9. So then my equation I put that k right here. So my equation is y equals 9x. Okay, so then I can use that equation that I found, and they want me to find x when y equals 63. So I have y, and I have k now, right? So I have y equals 9x. Well, if I say 63 is equal to 9x, I can find out what x equals. I divide both sides by 9. So x would be 7. And I could find anything. Like if I could find y when x is, give me some number.
10.
10? Okay, so I can find y when x is 10. I just use the same equation again that I just, that I came up with. And I can plug in x. So when x is 10, y would be 90.
Oh, so you have to add your text to it.
So if they give me y and x, I can find k, and then once I have k, I can find any y or any x if they give me one of them. And direct variation is the distance equals rate times time. And you think about it. Well, you're driving, right? The longer you drive at whatever speed you're driving determines your distance, right? So it makes sense. So if a jet is traveling 3,420 miles in 6 hours, so we have distance and we have time. What we want to know is rate. So I've got 3,420 is equal to some rate times 6 hours. If I divide both sides of the equation by 6 hours.
So that's the mix? Yeah. It's like cute. This is a puppy, though. Probably.
Is yours like a puppy or fully grown?
She's fully grown.
I think this was fully grown.
That's kind of cute.
Yeah.
For a chihuahua though.
Does it look like this?
Hold on.
Half or
Okay, let's finish this up. We found our rate, right? It's 570 miles per hour. So our plane is going 570 miles per hour times time. So distance is 570t. And we want to make a graph of this. Now, obviously, I cannot make each one of these little squares 1 mile, right? That would be ridiculous. I would need a giant graph. But I can make them each, like, say, 100. So this would be 200, 300, 400, 500, etc. And then I can make these an hour, 2 hours, 3 hours.
The farther they go, the higher it gets.
Right? So if I am at 1 hour, I will have gone 570 miles. So if this is 300, 400, 500, 570 is going to be kind of about in there, right? And I always go through 0, 0, because if I've gone 0 amount of time, I have gone 0 amount of distance. Does that make sense? Actually, you know what? I'm going to space this out a little bit more. Sorry. I'm going to make this one,
Yeah,
this
so
2.
that
But you can leave it. It'll look better on the board. It's the same exact thing. It'll just look better up here. So this is 2, 3, 4, 5, almost 6. Oops, almost 6. And then you just connect the dots. So like I said, it'll be the same thing. You connect your dots. Okay, so that's how we would graph it. And like, so yours is more squished. It's like right here.
Yeah.
But it's
So-
okay. It's the same idea. Mine's just more spaced out so you can see it better on the board. How many hours will it take to fly 6,500 miles? Well, we can take that 6,500.
Right? The first one was in an hour, right?
Yeah. And that's 570 times t. Divide both sides by 570. And that's going to be about, so I'm going to use these squiggly equal sign means approximately or about. So it's going to be about 11 hours.
If you were going that fast, shit.
Okay, a sequence is just any list of numbers. Or a set of numbers. Okay, the terms of the sequence. Oh, sorry. I forgot to write in a specific order.
This is a.
Any.
Oh, any.
Yeah. So they're in a specific order. The terms are the numbers. Okay. Okay, there's different kinds of sequences. You can just move
Oh,
that.
never mind.
There are different kinds of sequences. There's arithmetic, geometric, things, Fibonacci, things like that. And arithmetic sequence is like the most probably simple. In an arithmetic sequence, the terms terms are the same distance apart if you're talking about numbers. So you add or subtract the same number. Okay, so like if you talk about just like numbers when you're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you add 1 each time, right? You add 1 to 1, you get 2. You add 1 to 2, you get 3. You add 1 to 3, you get 4. We're adding 1 every time. Well, that number that you add or subtract every time is called the common difference. And technically, it's added. If it looks like subtraction, all you're doing is adding a negative. So if we take an example, if I go 3, 5, 7, 9, 11, okay, these are the odd numbers. To get from a 3 to a 5, I add 2. 5 to 7, add 2. 7 to 9, add 2. 9 to 11, add 2. So every time I'm adding 2, that makes it an arithmetic sequence. If I'm adding the same single thing every single time, it's arithmetic. If I take, let's say I start with 33 and I go down to 29, 25, 21, 17. To go from 33 to 29, I subtract 4. Subtract 4, subtract 4, subtract 4. So my D is actually -4. Because it's the same thing as adding -4 each time. How do we identify an arithmetic sequence? To go from a 4 to a -4 to -2, I have to add 2, right?
E.
And to go from -2 to 0, I add 2. To go from 0 to 2, I add 2. These are all the same, so yes, it's arithmetic. I can't spell today. Okay. Now this,
Yes, what?
arithmetic, this word right here.
Oh.
Okay. Here we need to, in order to figure this out, first of all, I'm going to have to come up with my common denominator because I can't add fractions without a common denominator. So my common denominator in all these is going to be 16. So I'm going to turn them all to 16ths first. So to turn a 2 to a 16, I multiply the top and the bottom by 8. To turn an 8 into a 16, I'm going to multiply by 2. To turn a 4 into a 16, I multiply by 4. And then 13 16ths is the same.
All 16 stays the same.
Yeah, because it's already 16. So I gave myself my common denominator of 16. So I multiplied here, I multiplied the top and the bottom by 8. Here I multiplied the top and the bottom by 2. Here I multiplied by 4, top and bottom. Now to go from 8 16ths to 10 16ths, I'm going to add 2 16ths, right? Because to go from 8 to 10, I add 2. To go from 10 to 12, I'm also going to add 2. But to go from 12 to 13, it's only 1.
12 to what? 18?
12 to 13.
Oh, that's a 13.
So no, this one is not arithmetic because these don't all match. Okay, so if you recall, these are D, right? So D must okay, so the D has to be the same every single time. Okay, to find the next term, first we find D. So to go from a 15 to a 9, I'm going to subtract 6, right? To go from a 9 to a 3, I'm going to subtract 6. And to go from 3 to negative 3, I'm going to subtract 6. So to find that next term, I take negative 3, and I subtract 6 from it. So negative 9 is the next term. Okay, and if I wanted to find the next term after that, I would take that negative 9 and I would subtract 3, and so the very next term after that would be negative 12, and so on. I would just keep subtracting 3 each time. Okay, here to go from a 9.5 to an 11.
Wait, don't you mean 6 and not 3?
That's what I meant exactly. Thank you for correcting me.
Fired.
You can't fire me.
Pull up Donald Trump.
So that should be negative 15. Thank you.
You should give me 20 points for just figuring that out for you.
She a student?
Yeah. I add 1.5 and I get 15.5.
Is that a pickle? I hate pickles.
All right, the nth term in a sequence just means like any random numbered term. Like let's say I have this sequence here. So this is the first term, second, third, fourth, fifth, sixth. Yeah, I could randomly pick one. I could say, what is the 27th term or something, right? Now you don't want to have to add or subtract 6 or add negative 6 27 times.
Multiply.
To get to the, no, you can't multiply, but you know what I'm saying, you don't want to have to deal with it that way. So there's a formula, it's called the recursive formula, and you can find any term in the sequence that you want it, and it's called the nth term. And the way the formula goes is, sorry, hold on. It is, let me pause this real quick. I'm sorry, this is not the recursive formula. It's the explicit formula. Okay. Sorry about that. I'm getting my formulas mixed up. This is the explicit formula. And that is a to the n is equal to the very first term, which is a sub 1, plus d times n minus 1. Okay? Where d is that common difference. Okay? A sub 1 is the first term in the sequence, and n is the number of the term you want. Okay. So if I want to find the nth, term, not therm, of the sequence negative 12, negative 8, negative 4, 0. First I find out what is d. So if I take negative 8 and I subtract negative 12, I'm adding 4 to each time. So d is negative 4. Or sorry, d is 4, not negative 4. Okay. So my formula to find the nth term of this particular sequence is, I would say a to the n is equal to the first term, which is negative 12, plus 4 times n minus 1. Okay. So if I want to find the ninth term, this number right here is n. So a to the n, or the ninth term, so you could put a 9 there if you want, is equal to negative 12 plus 4 times 9 minus 1. So that's negative 12 plus 4 times 8. So that's negative 12 plus 32. So it's 20. If I wanted to find the 45th term, so I do negative 12 plus 4 times 45 minus 1. So it would be negative 12 plus 4 times 44. So it would be negative 12 plus 176. So 164. And see, and you wouldn't want to do like 45 terms. You wouldn't want to have to keep adding 4 and like 41 more times to get to this number. Right? So this formula saves you doing all that over and over and over again, adding. Section 5, so we're going to move on to section 6. Proportional and non-proportional relationships, okay? So, proportional relationships are kind of the same as a direct variation. So what you get is okay, and what that means is like for example, y equals 3x. Okay, if I have x and I have y, if I plug in 0 for x, I get 0 for y. If I plug in 1 for x, I get 3 for y. 2 for x, 6 for y, 3, 9, etc. Right? Every x I plug in, I multiply it by 3, and that gives me the y.
Why you put the slash between the equal sign?
This means it does not equal.
Uh,
Yeah, so that's right. So anytime you see that, it's so k cannot be 0. And you get a nice graph through the origin. Oops, that's a bad line. Something like this, or facing the other direction, but you get a nice straight line graph through the origin. Okay, and it's in a ratio. It's a proportional relationship. If I take these right here, I can make a proportion, and it's true. That's why it's called a proportional relationship, because I can take the set of points and I can make it into a proportion. And then I could say 2/6 is the same thing as 3/9. This is true. Because remember, we check proportions, we cross multiply. 2 times 9 is 18, 6 times 3 is 18. It's the same number, so it's a true proportion. That's why they're called proportional relationships. What we're going to do is we're going to write an equation to describe this relationship. He's a professional trainer. He gets bonus pay for each client he sees. If he sees 1 client, he gets 45. 2 clients, he gets 90. 3, 35. 4, 80. So we want to do, to write an equation, to go from 1 to 2, I added 1, right? Added 1. Added 1. Added 1. To go from 45 to 90, I added 45. Here I added 45. Again, adding 45 and adding 45. These are the same each time. Okay? So, what I can do is, this part is the change in y. Because the bottom is always y, top is always x. So this part is the change in x. And slope can be defined also as the change in y over the change in x. So we get 45 over 1, which equals 45. And we can double check that. 1 times 45 is 45. 2 times 45, 90. 3 times 45, 135. 4 times 45 is 180. 5 times 45 is 225. So if I multiply by 45 each time, this is true. You want to always double check that. Does that make sense? Okay, so so what we have is our bonus is 45x. So bonus pay is equal to $45 times the number of people. Because our slope is the same as our k, right? Now we want to know how much money is he going to make if he sees 8 people. Plug 8 in. He'll get $360 bonus pay. So since it's not a direct variation, because of this, we have to figure these out a little differently. I mean, it's the same process, but you'll see that it doesn't quite work the same. To get from a 1 to a 2, I'm adding 1 each time, right? To go from 9 to 12, I'm adding 3, 3, and 3. So my change in y, that's the bottom, and I have the change in x at the top. So my slope is equal to 3 over 1, which is 3. Here's the difference though. Before, on that last page, when we said 1 times 45 equals 45, 2 times 45 equals 90, 1 times 3 does not equal 9. Two times 3 is not 12.
What you said? 2 times 3 is not 12, you said?
No, it's not 12, right? Here, I'm going to go backwards just for a second. Here, when I did 1 times 45, I get 45. 2 times 45 is 90. But 1 times 3 is not 9. 2 times 3 is not 12. 3 times 3 is not 15. 4 times 3 is not 18. So what I have is 1 times 3 is 3, right? But I need 9. How do I turn a 3 into a 9?
Subtract? Oh, you mean turn a 3 into a 9?
Yeah.
Yeah.
Well, it's always gonna be a plus at the end here. See this plus b? So we're gonna add, how much? If I add 6, I can get 9, right? And with that 2 times 3 not equaling 12, 2 times 3 equals 6. If I add 6, I get 12. Here, 3 times 3 is 9. If I add 6 to that, I will get 15. 4 times 3 is 12. If I add 6 to that, I would get 18. So this plus 6 right here is very important. You have to find out what do you need to add or subtract to make it work. So what I get is y is equal to 3x plus 6. This
that
is
a
my
one?
3. Here's where I get that 6. Is what a 1 here?
Yeah.
Yeah, 1 times 3. Now, function notation. Standard notation, function notation. So all you have to do to put it into function notation is replace the y with the f of x. Okay, so this is function notation. And this is standard notation. So plus 1, plus 1, plus 1, minus 1, minus 1, minus 1. So my slope is that change in y, right, over the change in x. So I've got minus 1 over positive 1, so it's negative 1.
Oh wow. Not that fast.
For real.
Alright, so now I found the slope. But 1 times negative 1, does that equal 3?
Yeah.
No. And 2 times negative 1, does that equal 2? 2 times negative 1 equals 2? No. 3 times negative 1 equals 1? No. So obviously something's missing here, right? Whenever you take the first and multiply it by the slope you find and it doesn't equal the second, you're looking for something else. Bless you.
Thank you.
So what I do know is I know that 1 times negative 1 equals negative 1. Okay. Well, I want 3. What do I have to add to negative 1 to equal 3?
Add the one.
I'm looking for something to add right here. If this part equals negative 1, so negative 1 plus what equals 3?
Or 3.
Negative 1 plus 3 would be 2.
4.
4. Right? Negative 1 plus 4 is 3. And we'll double check it here. 2 times negative 1 equals negative 2. So I want to add something to that so that I get positive 2. If I add 4, I get negative 2 plus 4. That does equal 2. So it works. So my equation then becomes y equals negative 1x plus 4. Because this is m and this is b. And if you want to put that in function notation, I replace the y with f of x. And I get f of x is equal to negative 1x plus 4. Or you can also write it without that negative 1. You can just put negative x plus 4. This is actually more standard to not put the ones in there. Okay, your homework for tonight. You have those 4, 5, and 6. 3.4, 3.5, and 3.6. Worksheets.